Hello students, welcome back to our channel. Today I am going to discuss about the charge to mass ratio of electron. In our previous class, we also learned about the introduction of atomic structure. That means the definition of atom and also the subatomic particles. What are the subatomic particles? Electrons, protons and neutrons. These three are the these three are the subatomic particles. So among these three subatomic particles, we also learned the discovery of subatomic particle electron, discovery of one of the subatomic particle electron by J.J. Thomson. So he did the experiment by using the cathode ray discharge tube, and finally he concluded that the negatively charged particles contain electrons. So this is all about in our previous class. So now we are going to learn about the charge to mass ratio of electron. So after the discovery of electron, J.J. Thomson also want to discover the E by M value of electron. So for this measurement of the E by M value, he also used the same discharge tube with some extensions. Okay, he also used the same discharge tube which he was used in the discovery of electron with some extensions. So by this E by M value is also called as specific ratio. That means charge to mass ratio of electron is also called as specific ratio or E by M ratio or charge to mass ratio of electron. This is also one of the important point. It will ask you in your competitive exams. So that is the what is the another name of the charge to mass ratio of electron? That is the specific ratio. So he calculated the E by M value by using the cathode ray tube in the presence of electric and magnetic field. In the discovery of electron, he only used the cathode ray tube, but for the measurement of the ratio of E by M value, he used this cathode ray tube in the presence of electric and magnetic field. This is the only difference. Now by measuring the deflection of the particles, he determined the value of E by ME. So by using the deflection of particles, already we also learn the particles move from cathode to anode. Okay, so how these particles are deflected by measuring this deflection, these different types of deflections, he determine the value of E by M. So while he conduct an experiment, he also postulate some three important points. So that is the amount of deflection of the particle is mainly depends upon these 3 points. So what are these 3 factors? Let us discuss. The first factor is the greater the magnitude of the charge of the particle, greater is the deflection. That means if the particle contains heavy magnitude of the charge, if the particle contains high magnitude of the charge, the deflection will also be greater. That means the deflection will also be increases. If the particle contains high magnitude, the deflection is high. That's it. Next, coming to the second factor, less the mass of the particle, greater is the deflection. Okay, so if the particle have less mass, the deflection of the particle will be very high. If the particle have high mass, the deflection of the particle will be less. That means the mass is inversely proportional to the deflection, and also the deflection is inversely proportional to the mass of the particle. So this is the second factor. Next, coming to the third factor, greater the strength of the electric and magnetic field, greater is the deflection of the particle from its original path. That means if the strength of the electric and magnetic field is increased, the deflection of the particle from its original path is also increased. Okay, these mainly the deflection of the particle is depends upon these 3 factors. So now coming to the experimental part, already I told you he used the cathode ray discharge tube for the measurement of E by M value. So this is the cathode ray discharge tube. He extended the cathode ray discharge tube and he also adjusted a fluorescent screen for the to observe the deflection of the particles. In the absence of electric and magnetic field, the first point, when in the absence of electric and magnetic field, the particle move and hit the point at B. Okay, when after that he only introduced the electric field in the discharge tube. So at that moment the particle will deflect and hit the point A at the discharge tube, one end of the discharge tube. And after that he also introduced the magnetic field in the discharge tube. So at that time the particle deflects and hit the discharge tube at point C. So he finally observed that when the presence of electric and magnetic field, the deflection takes place in the particles. So due to this experiment, he finally measured the value of E by M by using the deflection. By using the measurement of deflections, he finally concluded that E by M value is equal 1.75880 into 10 power 11 Coulomb kg inverse. So where me is the mass of the electron in kgs and E is the charge of the electron in coulombs. So the E by M value is Coulomb per kg or Coulomb kg inverse. So finally the value E by M value is equal 1.758820 into 10 power 11 Coulomb kg inverse. So this is the important point. It will ask you in your competitive exams and as well as your board exams also. Okay, next, finally in this experiment the electrons contains the negative charge. And next, coming to the another topic, charge on the electron. So the charge on the electron was found by Mulliken in the year of 1909. After the discovery of E by Me value, J. Thomson discovered the E by Me value. Mulliken want to discover the charge on the electron by using the oil drop experiment. By using the oil drop experiment, he found out the charge on the electron. So finally, the charge on the electron is minus 1.6 into 10 power minus 19 coulombs. So but present the accepted value, after present accepted value is minus 1.6022 into 10 power minus 19 coulombs. This is the actual charge on the electron. Here we assign the negative charge. Why? Because the electron always contain negative charge. That's why the charge of the value of electron is minus 1.6022 into 10 power minus 19 coulombs. So by using this value, the mass of the electron was also derived by using this value. So how? Let us see. So mass of the electron Me is equal to E by Me. So this is the formula. By using this formula, the mass of the electron we will derive. So that is equal to the value of E. That means the charge of the electron is 1.6022 into 10 power 19 coulombs by E by M value. Also the E by M value. We put the E by M value here 1.758820 into 10 power 11 Coulomb kg inverse. So after that the finally mass of the electron is 9.1094 into 10 power minus 31 kgs. So this is the mass of the electron. Okay, and this one is the charge of the electron. This is the charge of the electron, this is the mass of the electron, and finally this is the E by M value of the electron. These three values are very important in your competitive exams. So this is the today's topic. If you like the topic, please subscribe our channel and click the bell icon. Thank you for watching.